No.
We are the Windy Waves team, comprised of Xinlong, Hadley, Besing, Gustavo, Coelho, and Soundarya, Sridhar. Our mentor is Del-Castillo-Negrete. And for our DesingSafe 2021 hackathon, our project was improving the ADCIRC user experience with DesingSafe with parameter customization and outputs visualization. So if you're like many of us on this team, you probably are not that familiar with ADCIRC, but ADCIRC is a system of computer programs that solves time-dependent free surface circulation and transport problems in 2 and 3 dimensions. These programs utilize finite element method in space, allowing for the use of highly flexible and unstructured grids. Typical ADCIRC applications include the prediction of storm surge and flooding, modeling tides and wind-driven circulation, larval transport studies, nearshore marine operations, dredging feasibility and material disposal studies, and many more. Output files from ADCIRC can contain temporal varying and spatially varying variables such as water surface elevation, water velocity, wind velocity, and atmospheric pressure. And these can be in either 2 dimensions or 3 dimensions as specified by the user during input. So the objective for our hackathon project was to improve the ADCIRC user experience, especially for new users, by facilitating parameter customization and output visualization. And our workflow for this was first to identify key parameters in the ADCIRC input files that someone might want to change, and then take these parameters and develop a user interactive notebook to customize these inputs and controls. These could then be used to run an ADCIRC job successfully. And the outputs can be post-processed for visualization, including them even in the Haz Mapper application, which is also part of DesingSafe. So the files that are necessary for a basic ADCIRC model run include gridded mesh data in a Fort14 file, and also the basic model parameterizations in a Fort15 file. And this file can contain up to 40 plus different parameterizations just in this basic file. These can include, for example, the amount of time you wish to simulate, the time set for calculations that you are doing, the type of model you wish to run, and how complex you want that model to be, and even the inclusion of advective terms in your calculations. So we wanted to develop an interactive Jupyter notebook to aid the users in navigating these parameters, and we chose 10 of these to do this.
Thank you, Hadley. So this part of the project, parameter customization, is a Jupyter notebook that is very helpful for first-time users to understand a little bit about the input files, as well as have the opportunity to change up these parameters for the ADCIRC job runs. So on DesingSafe, whenever you want to run an ADCIRC job, you have to mention what the directory location is. And that is a folder that contains these input files, such as the 14, 15, and the 13 files that Hadley mentioned. Some of the most commonly used ones are the 14 and 15, and due to limitation in time for hackathon, we narrowed it down to 15 and the 10 parameters. So essentially what this Jupyter notebook does is let the user choose what parameters they want to change, and then save that as a new Fort15 file. So in this case, you can see that the user changed the job description, job ID, as well as the length of the ADCIRC run, which is the 6th parameter here, which is RNDAY. And it also gives you a neat little description of what each parameter means as and when the user chooses that parameter. So if we can move on to the next slide, we can also talk about what the other parameters are that the user can change. So with every ADCIRC job run, you will have a different location or a folder name, and you can mention where the location of this folder is so that it can extract that Fort15 file, and then they can go in and change the parameters. And in the end, instead of rewriting these Fort15 files, it's going to be saved in a new location. So the users can mention what that folder name is. And apart from copying the new Fort15 file, it's also going to copy the other input files associated with that job run. So that way you don't have to do any new cut, copy, paste for running an ADCIRC job. You just have to mention what the new directory location is. And in the end, this Jupyter notebook is very useful for first-time users. It's going to save some learning time for them, and it's also a nice introduction for them to experiment with these ADCIRC files. We can definitely expand the scope for this part of the project to include more code files, like I mentioned previously, the 13, 14 files. And if we want, we can take it one step ahead and suggest the users with some job parameters that can optimize the ADCIRC runs, as well as give them kind of experiment with these files and see what outputs the ADCIRC throws out. So I'm gonna hand it over to Gustavo to talk about how we process these ADCIRC output files and visualize them.
Thank you, Soundarya. I'm Gustavo, and this is the part of the work that we present here about the visualization. So the outputs from ADCIRC are given in netcdf files, and is not a straightforward file format for new users or new people on the code environment. So here we create a Jupyter notebook with Python functions to visualize a few files that are very interesting for the user, like the maximum elevation and the maximum velocity, maximum wind speed, and minimum atmospheric pressure. So we condensed the functions to visualize those outputs in a Python function, and in a very easy, straightforward calling, you can visualize the outputs from the model. And then we proceed with the integration of these outputs with the Haz Mapper. So the user can visualize, quickly create a visualization from the outputs, analyze the results, and then can export to the Haz Mapper. Xinlong will explain now.
Okay, thanks, Gustavo. So we started from the ADCIRC output files. Then we loaded the output file to Kalpana and converted to shape files. Then we use GeoPandas to convert it to GeoJSON files. So we then loaded the GeoJSON file into Python to customize it for the Haz Mapper. We added the style object with the color field to the JSON file. We used the hex color code, and the color was converted from the water elevation. We then saved the modified JSON file and uploaded to the Haz Mapper. So consequently, in the Haz Mapper, we used contours with different colors to represent different water elevation, as shown in this figure here. So we have contours with different colors to represent a different water elevation. I think Gustavo will make a conclusion for our project.
So in Haz Mapper also, it's a very good ways that we can share the results, and also with other people in your work, as well as we can click on the map and look for the elevations or the information that is given from the result of the ADCIRC. And as a conclusion, ADCIRC is a numeric model that involves complex file management and coding skills. So with this work, we try to bring and narrow this gap between a new user and an experienced user, and helping on this experience. Our notebooks are not exhaustive. We had like a 48 hours hackathon to produce that, but it's a great starting point for future integration into DesingSafe cyber infrastructure, and as well as a good start point to start getting experience with ADCIRC. And also the hackathon was a great experience for our team, giving exposure to ADCIRC for many who have never used it. So in your group, we have people who have never used the ADCIRC first and before, so it was a great way to create this for new users. This is the member roles on the team. So Xinlong was responsible for importing and customizing the JSON file to Haz Mapper. Hadley identified the ADCIRC parameters for the notebook. I was responsible for the outputs, post-processing for visualization in the Jupyter notebook and the Haz Mapper. And Soundarya was responsible for creating the interactive Jupyter notebooks for 15 validating. And with that, we thank you for all your attention, and we'll get questions.